Hi, in this video, we will learn how to assess the hearing damage by using the LEQ versus the LAE. LEQ is called the equivalent continuous noise level, and the LAE is called the alternative energy or the sound exposure level. So far, you have learned how to measure the sound in dBA, which is the 8-week sound pressure level that is correlate to the 40 Fs loudness of the human hearing response. So this value that you measure at a particular time is about the level or the magnitude. To assess the hearing damage potential of a given sound environment, we need to consider both level as well as the duration. Imagine that you are exposed to a loud sound with 40 dBA for 4 hours compared to another guy who is exposed to the same sound level as well. However, the duration of exposure are different between these two guys. One stay for 4 hours, another guy stay for 1 hour. So which guy will suffer more hearing damage? In this case, the sound level are the same. Therefore, the longer the time of the exposure, the more hearing damage the person will receive. Bear in your mind, when we want to assess the hearing damage, we must consider not only the level but also the duration. Imagine yourself to be this guy who works 8 hours per day. And you can see for the first hour, this guy monitor the worker inside the workshop, and the rest he work in the office. The 8-week SPL in the workshop is 100 dBA, which is much higher than the office. Therefore, we can say workshop is more noisier than the office. If you measure the sound level, which is the XPL in dBA unit, over the time, then you will see initially for the first hour, the sound pressure level is around 100 dBA. And the remaining 7 hours, you will have the 70 dBA. Consider the sound level as well as the duration. For various periods, we can obtain the LAEQ here equal to this value, which is the 8-week equivalent continuous noise level. If the unit of SPL is in dB, then in this case, you will obtain the LEQ, which is in dB unit also. So LEQ is the one without the 8-week. So the unit is dB in this case, and if you measure LAEQ, it will be in dBA. So these are the difference between these two terms. So why do we compute the LAEQ? We compute the LAEQ because this value gives us the knowledge about the average sound energy that is equal to the fluctuating noise in the station 1 here plus station 2 here. So if you take the sound energy of the station 1 plus the sound energy at the station 2 here, then the total energy will be much equal to the average sound energy here. The LAEQ consider not only the level, which is the SPL in dBA, but it also consider the time duration that the person exposed to the noise, that is the period. Therefore, we can use the LAEQ parameter here to measure the hearing damage potential. So you can see here, to determine the hearing damage potential of a sound, we can use the 8-week equivalent continuous sound level, or in the symbol we write the LAEQ. In practice, we can use the integrating sound pressure meter in order to measure the LEQ or the LAEQ. So we know that the sound pressure meter here can be used to measure the sound pressure level in either the dB unit or the dBA unit. integrating here means that we can integrate stopwatch into the sound pressure meter, where it takes the level and also the duration simultaneously. So by doing this, it can compute the average sound energy by using the equivalent continuous sound level. Normally, integrating sound pressure meter is much more expensive than the sound pressure meter. So in this case, if you are not afford to buy this, then you can consider to use sound level meter together with a cheap stopwatch, so you can measure the SPL change over the time, and the time can be obtained by using the stopwatch. Then only you use the formula to compute the LAEQ. So you see, if you have this kind of measurement by using the sound level meter and also the stopwatch, so we can use manual calculation to obtain the LEQ in this case. However, if you use the integrating sound pressure meter, it can compute the LEQ or the LAEQ automatically inside the instrument. Once we obtain the LAEQ, then we can compare to the legal standard. So for example, if let's say a legal standard say that the noise limit must not exceed 85 dBA. So in this case, you see the working environment is not safe because it exceeds the noise limit, which is 85 here. So in this case, you might consider to reprint the activity. For example, instead of taking 1 hour for the first station, you might consider to reduce it to 30 minutes. Or even lesser time in order to fulfill the standard. To answer how much time is stable to work in the station 1 and station 2 in order to fulfill the standard, you must learn how to compute the equivalent continuous sound level first. So this is the formula we use to compute the LEQ, which is the equivalent continuous noise level. If you measure the sound pressure level at station 1, 2, 3 and so on until the last station in the dBA unit, then in this case you will obtain the LAEQ. If you measure the L1, L2 until the Ln to be dB only, then in this case you will obtain the LEQ. So this is the case when the measured sound pressure level is in dBA. Then this equation here will be changed to LAEQ. T1, T2 and so on until Tn is the time that you spend at the station 1, station 2 until the last station. So this is the definition for the T1 until Tn. And the capital T here is the duration of the working hour. For example, if you work 8 hours per day, then capital T here will be equal to 8 hours. And you need to be careful, the unit for the small letter t here and the capital T here must be the same. So if you use the unit to be hour here, then T1, T2, T3 must be expressed in the same unit, which is in hour. So if you change this in terms of the minutes, where you multiply with 60 to obtain the minute unit, then in this case T1, T2 until Tn station must be in minute as well. So the unit for the T here must be the same. Lastly, you need to be careful. So this operation you need to compute first. So you need to compute this, only you take the log. So many people make the mistake where they take the log first and divide with the T, which is wrong. Let's try to use this formula to solve the previous problem. So you have 2 stations previously. Station 1, the level is in dBA. So for the first station you have 100 dBA. And the duration T is equal to 1 hour. Therefore the unit is in hour. For the station 2, the sound pressure level is equal to 70 dBA and the duration is equal to 7 hours. Since the unit is in dBA, therefore in this case, you are going to find the LAEQ EQ, which is the 8-week equivalent continuous noise level. Therefore, is equal to 10 log with a big bracket where you take the division with respect to capital T, and since the capital T is equal to 8 hours per day, therefore you can substitute. So this is your L1 and L2. After you substitute, you should obtain 10 to the power of 10 and 10 to the power of 7. So this is your T1 and T2. Substitute inside the formula, you should obtain 1 multiplied with this plus 7 multiplied with this. After you compute, you should obtain LAEQ equal to 91 dBA. So you can compare to the previous answer, which is the same. Assume that the LAEQ must be less than 85 dBA according to some legal standard. If the working environment at these two stations are fixed and cannot be changed, then we need to consider to adjust our working time at these two stations. Since the first station is more noisier than the second station, we might consider to reduce the working time in this station. Let's form a new equation based on this condition. So in this case, your LAEQ is equal to 10 log with the bracket that is divided with the 8, since the duration of the working per day is still remain. The sound pressure level at these two stations are still remain. Therefore, we can write there 10 to the power of 10 and also the 10 to the power of 7. Since we are not sure how much time we should spend for the station 1, therefore we can just substitute T1 inside and also the T2 inside here. In this case, you are working fully, where T1 plus T2 equal to 8. Therefore, from this relationship, T2 is equal to 8 hours minus with T1. After we substitute this inside the T2, then you should obtain this equation. Then you can continue to solve this equation. Move the 10 to the right hand side. So you need to divide it with 10 to obtain 8.5. Log, convert to right hand side, you obtain 10 to the power of 8.5. Divide 8, move to the right hand side, you obtain multiply with 8. 8 multiplied with 10 to the power of 7, move to the right hand side, you obtain negative 8 multiplied with 10 to the power of 7. So this can be eliminated. Lastly, T1 here can be extracted out. So this will change to 1. And then you have T1 multiplied with 10 to the power of 10. After you extract the T1, then you only obtain minus 10 to the power of 7 here. We move this term to right hand side, then you need to divide it with the 10 to the power of 10 minus with 10 to the power of 7. Let's compute this. After the computation, you should obtain T1 less than 0.245 hours. If we substitute this inside the formula, you obtain 8 minus T2 equal to T1 here. And if we change the 8 minus to the right hand side, we obtain T2 greater than 8 minus 0.245 hours, which is equal to 7.755 hours. So you can see from this solution, it suggested we should work in the station 1 shorter and work in the station 2 longer. So the 1 hour previously is reduced to be 0.245 hours, which is shorter, and T2 previously is 7 and is increased now to be greater than 7.755 hours. If we choose the T1 equal to 0.24, so we can substitute inside here 0.24, then your T2 will be equal to 7.76. So we can substitute inside 7.76, which can be obtained from this relationship. If we compute the LAEQ again, we obtain the result to be 84.9, which is less than the noise limit, which is equal to 85 dBA. So you can see by adjust the working time in each station. Now we success to fulfill the standard. Now you should know how to compute the LEQ or the LAEQ. In the second scenario here, imagine you are the person here who work in these 3 stations per day, and you are working 8 hours per day. Initially, you are working at the station 1 here, which has the largest sound pressure level. So you work for this period, let it to be T1. Then you continue to work at the second station here, which has moderate sound pressure level at 80 dBA. So this is your T2. Then you go back to the office. So this is your T3. And this is the corresponding SPL value at T3. So you continue to go back to 2 here. So this is your 3. And then this is 2. And this is 1, 2, 3. And this is the 2. And this is 3. Since the sound pressure level is measured in dBA unit, therefore we can obtain LAEQ from it. So it's equal to 10 log, and in the bracket you need to divide with the working hour per day. So in this case the working hour per day is 8 hours, so you can substitute 8 inside. So in the first station, the SPL is equal to 110 dBA. Therefore, you have 10 to the power of 110 divided by 10, you obtain 11 here. For the second station, the SPL is equal to 80 dBA. Therefore, you obtain 10 to the power of 80 divided by 10, you obtain 8 here. So you continue for the third station, you have 70 dBA. Therefore, you have 10 to the power of 7 here. Then you continue to refer to this figure in order to find the time that you spend for the station 1. So take the summation of the time here and here, then put the total time for T1 here and multiply with the corresponding level. Then we continue to compute the time spent in station 2. So we need to take the summation of T2 for all of this region. Then you obtain the T2 total. So you continue to substitute the T2 inside here and multiply with the corresponding level. Lastly, you need to continue the same procedure for the station 3, where we take the summation of all the time that you spend in the station 3 here and substitute the total T3 inside it and multiply with the corresponding level. So by doing this, so after you compute the equation here, then you should obtain the LAEQ that you spend through these 3 stations. We have more example here. So in this example, you are going to compute the equivalent continuous noise level over 8 hours day for a worker exposed to the following noise level and duration. So in the first station, this is the corresponding level and also the time. So this is the second station, and this is the corresponding level and time. Since we are computing the sound pressure level in the dBA unit, therefore we are actually computing the LAEQ. So we can substitute the L1 and L2 inside the formula here, and this is your T1 and T2. So we can substitute inside. So the time is in the hour, so we need to ensure the T1 and T2 have the same unit with the capital T, where the capital T is equal to 8 hours per day. After you solve this, you should obtain this result. And normally we express the final answer closest to 0.5 dBA. What if you reduce the time 2 into 2 hours and all the parameters remain? So in this case, you need to substitute the T2 equal to 2 and compute the corresponding result. In this case, LAEQ is reduced to 114 dBA. So you need to be careful. the total working time capital T might not be equal to T1 plus T2 in some cases. So this is not always true, like this case. So you are working for 8 hours per day. So in this case, you spend 5 hours for the first station and 2 hours for the second station. So 8 minus with T1, T2, you obtain the remaining time equal to 1 hour. So imagine you spend 1 hour for rest or for lunch time. So during this 1 hour, it's assumed that the worker is exposed to a very low noise which can be neglected in the calculation. In this example, you have the sound pressure level which is measured in dBA that is fluctuating over the time. So you can see the fluctuation is between 56 and 74 dBA. By using the formula for the LAEQ, then we can obtain the equivalent continuous sound level which is equal to 68 dBA in this case. Instead of using the previous formula for the computation of the LAEQ, we can obtain the value directly if you use the integrating sound level meter. So we have discussed this previously. So beside this instrument, if we use the dosimeter, you can also obtain the LAEQ directly. In fact, the LAEQ contains the same sound energy with the fluctuating sound pressure level over the time here. So this is known as the equal energy principle. By using the LAEQ, now we can set the maximum noise exposure allowable for the employees for a normal working day. The allowable LAEQ, based on two standards, which is the OSA and the ISO standard, are given in this graph. From the figures, ISO and OSA standard allow a worker to work under 90 dBA working environment for 8 hours continuous. For the OSA standard, the increment from 90 dBA to 95 dBA, which is 5 dBA increase, will cause the permissible exposure duration to be half, which is dropping from 8 to 4 hours. So if you are working in a higher noise area, for safety reasons, the working hour must be significantly reduced in order to protect our hearing. On the other hand, for the ISO standard, which is given in the dashed line here, by reduce the working hour by half from 8 to 4 hours, then the increment of the dBA is increased by 3 dBA only. If we compare it in the same sound pressure level at 95 dBA, so you see the OSA allowed the workers to work for 4 hours continuous. However, for the ISO standard, the workers is allowed to work lesser time, which is around 3 hours in this case. Therefore, ISO standard is more strict than the OSA standard. So far, you learned about the hearing damage. That is mainly contributed by the sound pressure level as well as the noise exposure time. By taking the sound measurement, we obtain the fluctuating SPL over the time, as shown in this figure. So we have learned how to compute the LAEQ, which is equal to this level that has the same energy as the fluctuating SPL here. There is another way to quantify the hearing damage. So besides the LAEQ, we can also quantify it using the SEL, or what we call the LAE, which is the alternative energy parameter. SEL stands for the sound exposure level, and it can be represented by the symbol LAE here, which is this. From the figure, you can see the main difference between the SEL, LAEQ, and also the fluctuating SPL. So let's say the fluctuating SPL has the period equal to 8 hours. So LAEQ has also the same working hour. However, for the sound exposure level, which is the LAE, the duration of it is specific to be 1 second. Although we represent the sound in terms of the fluctuating SPL versus the LAEQ versus the LAE here, all of these three formats have the same sound energy. The main function we express it in the LAEQ format is due to the standard. So you can see that for the ORSA and also the ISO standard, they define the noise exposure in terms of LAEQ. So why do we express the sound energy in terms of LAE in this case? The main function of having the SEL or the LAE measurement is to describe the noise energy of a single event, such as the vehicle passing by or an aircraft flying over. So you can see the SEL measurement here are normalized to only 1 second time interval. So in this case, the energy content of different type of noise event can be easily be compared. For example, in this case, you have two noise sources from the helicopter and aeroplane. For the helicopter, the equivalent continuous noise level is given over a period of 10 seconds. The LAEQ for the aeroplane is higher and it happens for a shorter period. So we can define it to be two events here. One is from the helicopter and second is for the aeroplane. So which event will contribute more noise, or what we say contribute more hearing damage? If you compare in terms of the LAEQ magnitude, then we say the airplane will contribute more noise because the magnitude is higher. If you compare in terms of the exposure period, then we will say the helicopter will contribute more noise in this case. So, which event actually produce more noise? To answer this question, we can compute the single event noise exposure by using the SEL or the LAE here. So the equation is given by this. Let's compute the LAE for the helicopter. So we substitute 130 inside the LAEQ and the period equal to 10 seconds. We substitute inside here to become this. After you compute this, then you should obtain the final result to be 140 dBA. And you should know this value represents the sound energy per second. So let's say the time interval here is equal to 1 second. For the helicopter is equal to 140 dBA. We repeat the same procedure to compute the single event noise for the aeroplane. So we substitute 140 dBA and 5 seconds inside the equation here. Compute it, then you should obtain 147 dBA. So when we plot the graph, you should obtain the LAE for the aeroplane. The magnitude is equal to 147 dBA for 1 second time interval. So when we compare the first event and the second event, the second event here contribute more sound energy. Therefore, it is contributing more noises. From the question, it's mentioned that during 12 hours period, there are 50 helicopters and 80 aeroplanes. So we are going to compute the LAEQ over a 12-hour period using the SEL information that we obtained here. Let's compute the LAEQ. Is equal to 10 log in the bracket, which need to divide with the capital T. So this capital T is referring to this 12 hours period. So we can substitute it with 12 hours. Then for the first event, the LAE is equal to 140. Therefore, the noise level is given in 10 to the power of 140 divided with 10. And we know this is in second. Therefore, we need to convert the unit of hours into second by multiplying it with 60 minutes and 60 seconds. For the second event, you have 147. Therefore, you obtain 10 to the power of 147 divided by 10. Lastly, you know that there are 50 helicopters for this event. Therefore, you need to multiply 50 to the corresponding noise level. And for the aeroplane is about 80 aeroplane. So you need to continue to add the 80 multiplied with the corresponding noise level. After you do the calculation, you should be able to obtain 120.19 dBA and is approximate to 120 dBA. So you should obtain this answer. You should obtain the same answer if you use the previous LAEQ formula. So let's try to use the previous method. So you have 50 helicopter and you need to multiply with 10 seconds and multiply with the corresponding noise level, which is equal to 10 to the power of 130 divided by 10, then you obtain 13 for the power. And you continue to add with 80, which is the number of times for the aeroplane, multiply with the period 5 seconds and multiply with the corresponding noise level, which is equal to 10 to the power of 140 divided by 10. So in simple, we write 40. And you need to divide with 12 hours, which is given in this information. And since the unit for the time is in second here, therefore we need to convert 12 hours into second as well by multiplying it with 60 minutes per hour and 60 seconds per minute. If you compute this, then you should obtain the same answer as well. If you forget the formula here to compute the single event noise exposure level LAE, we can directly derive from here. So for helicopter, it takes 10 seconds and the noise level is equal to 130 dBA. Then if we write the general formula for the helicopter, so T1 refers to the time duration per event, and also the LAEQ for the helicopter is equal to 130 dBA. So in this case, we want to convert to the LAE, where the magnitude here is equal to LAE. And we know the LAE is only lasts for 1 second. 1 second multiplied with this, then you should obtain this value. And let's move the 10 to the left hand side, then you should obtain log for this term. And 10 here can move to the left hand side, then you obtain 10 log. The multiplication inside the log function can be removed to become 10 log T1 plus 10 log to this term. By using the log operation, we can move the 10 here to the power here. And the 10 here can be cancelled with the power, and the 10 here can be cancelled with the log. So you only obtain 10 log T1 plus LAEQ for the helicopter is equal to the LAE. So we can substitute the T1 to be 10 seconds inside 10 log 10 plus 130. Then you should be able to obtain the LAE. If you compare the LAE for the helicopter that you obtained previously, you should obtain the same answer.